Greetings. This is a pre-recorded screencast for my prototype of an upgrade as a service done as a semester project during the fall of 2011 for EURECOM in Sophia Antipolis, France. This pre-recorded screencast is intended to be available in YouTube in order to be prepared for unexpected technical difficulties during the project defense and to provide additional hands-on documentation and record of what I produced during the semester. So without further introduction, here we can see the initial infrastructure of the setup. As you can see, I am running a few elastic computing instances in Amazon EC2. One of the instances contains the MySQL database and necessary front-end software we wish to replicate and upgrade into the new version. And as you can see here, we have it up and running in an HTTP server facing the public network, public internet, and we can work with it like any other standard MediaWiki installation. We can insert data there and see as it enters, and it's a pretty much a standard MediaWiki. The other computer here acts as an external control node, which is used to provide necessary instructions and setups for the computing cloud to the original system under replication and for the new dynamically created parallel universe instance going through the upgrade. So here we have connected into our control computer, giving us our friendly login echo as we open shells. It does not run much of a specialized software except for the configured EC2 tools needed to interact with Amazon Elastic Computing Cloud. And over here we can see the Git clone from our software repository. It is practically a direct pull from the latest version, which you can download from the project GitHub page. But we have also made our customizations to the config files, just to state the instance and database access details needed for replication in EC2. And we have also run it a few times, so there might be a few extra dynamically generated files here and there, which will be overwritten as we go during our demonstration. And here in the program folders we have the necessary scripts needed to perform this upgrade, and of course now I'm going to show you a sample execution and try to describe what is happening behind the screens. So the first software we need to run is the script creating the replica of the original Amazon instance running MediaWiki 1.4. And we can do that by just executing this create avs replica.sh tool. The tool reads the instructions from config.conf in order to instruct the Amazon EC2 to create the identical copy of the running instance. So as I run the script, it starts to show some amount of information of the execution. As you can see here, the output matches the information on the Amazon dashboard. We are replicating this instance ending with 182. It is notable that in this use case that we do not manage to go entirely without downtime, since the architecture we use to create the system replica is the one powering Amazon's own image cloning infrastructure. We require the system to shut down the original system for a minute for cloning the image. And we can see here that Amazon is working with new disk images for launching our replicated instances. And with a big data set such as Wikipedia, this kind of copying would of course make a single server system like we are running go down for some time. But for most scalable web applications, they are designed to withstand a number of shutdowns as servers naturally break down and are upgraded to handle different loads vertically and horizontally when you renew the servers and when you just add more servers. So we assume that in real life production case, we can replace this kind of replication with traditional node replication. Okay, now as the script has finished running and when we look back into the AWS console, we can now see that there's a new instance running. The instance is practically a one-on-one copy or clone of what the original computer was running before it got shut down for a few seconds. And when we get back here, our script happens to be nice enough to tell us what we need to do next. So we continue by running this setup replica, which copies the necessary configurations, software and scripts to the new parallel node, so that we can start moving our operations over there. So let's take the connection in to the newly created node. You can see that it has slightly different host names and IPs and such, and so it's an independent clone of the original, as I told you. So here we move into the instructed directory and follow the next steps forward. First of all, we establish our hookup to the original user-facing MediaWiki installation. It's a pretty standard SSH pipe our script here is starting, which reads the end of the MySQL query log of the original. And it's done by, since our computer is this replica of the original, we also have an out-to-date version of the same log file as is present in the original node. So in order to receive only the subset of changes, we take the line count from our query log, which represents the state the database was in just before it got shut down and replicated, and just take the tail of that line node number. And so as I can show you, every query made on the original 1.4 installation since the shutdown now appears in parallel node. And as we update the MediaWiki like this, we can see that the related logs appear in the log cache file this pipe creates. The second set of instructions contains all we need to perform the standard write-locking upgrade from MediaWiki 1.4 to 1.5. It actually downloads the necessary files from the subversion repositories of MediaWiki, and it copies them to folder readable by our Apache server. And after that, it runs the necessary schema-changing database scripts and alters the configuration for MediaWiki and Apache. So I can show you that in this different address where we enter with our browser, we now have another MediaWiki up and running. The 1.5 installation has slightly different symbol over there on the corner, but it's still running with a similar dataset with the old one. The articles are pretty similar, though there are some upgrades happening in the old version, of course, because we do not want to write-lock it. And after that, we can start the program doing the SQL translations. This script takes the log cache as a parameter. So when this program is run, it shows it has detected new changes in the log cache file. And right now we can see there is the same article modification I showed to demonstrate the SSH pipe earlier. Since we started the translator, the changes start appearing in the parallel version. And as I insert new data into this wiki, we can also verify that this edit also appears in the upgraded version. So in a real-life scenario, this recording of queries and appending them later allows us to have the old version receiving user interactions, while the new parallel version works out the upgrade uninterrupted. After the upgrade has been done, we can catch up with the modifications presented in the old version. When the two systems are in equivalent state, one just directs all users' traffic for the old one to point in the new node, and then we can stop using the excessive resources of virtualized cloud instances originally allocated to the old version by just shutting down the resources. care. So that's the screencast. For the source code and documentations, look up the GitHub address on the description of the video, and I hope this has been an enlightening experience for the viewer as much as it was for me. Thank you.